All right, my math community, let's go ahead and finish out these derivatives. So it's a couple derivatives we didn't talk about, like the derivative of ln of x and the derivative of e to the x. So since we already know the chain rule, I'm gonna just explain to you how this works with the chain rule. So the derivative of natural log will be 1 over the stuff that's inside the log, which is x, times the derivative of the stuff that's inside the log. And the derivative of x is just 1. So when you're going through school or class, they're going to tell you that the derivative of log of x is 1 over x. But they never tell you about the chain rule part. So when you get to something like log of x squared plus 3x, then you're kind of lost. And same with e. So the derivative of e will be the exact same thing you see, e to the x times the derivative of the exponent, which is 1. So again, when you're going through class, they're going to tell you the derivative of e to the x is just e to the x, but they don't tell you about the chain rule part. So let's go ahead and see why that's important. So what if I had something like ln of x cubed plus x? So now this derivative will be 1 over the stuff that's in the middle, x cubed plus x. But we need to multiply times the derivative of the inside. And that's not just 1 anymore. It's 3x squared plus 1. Therefore, this derivative, if you wanted to write it as one whole fraction, will be this ugly mess. Not just 1 over the argument. And that goes for e also. So if I had something like the derivative of e to the x cubed, well, again, this derivative will be the exact same thing you see, but you need to multiply it times the derivative of the exponent, which is 3x squared. So when they tell you that derivative of e to the x is just itself, no. Always think about the chain rule, because the chain rule will apply for e to the x's and ln of x's at all times. Even if you got to multiply times 1, just get used to using the rule.